In this section, we'll be looking at geometric applications. So here, for example, when we have the length of a rectangle is 3 inches longer than the width. The area of the rectangle is 108 square inches. We've got to find the dimensions of the rectangle. So we know we're talking about the area of the rectangle, and the area of a rectangle is found by multiplying length times width. So here, this would be our length, this would be our width. We also know that the area is 108 square inches, so we would have 108 equals length times width. However, we cannot solve anything when we have a length and a width variable here, because anything that we try to solve would still have a variable with the answer. So what we have to do is we have to use this other piece of information that we're given here, and that is that the length of the rectangle is 3 inches longer than the width. So the length of the rectangle is 3 inches longer than the width. Length is, tells us to put an equal sign. 3 inches longer than, tells us to add 3. And the width, we'll put that here. You also could write this as 3 plus W. It doesn't matter which order you put those in since it's addition. So, because length and W plus 3 are equal to each other, that means that we can replace length with W plus 3. That will look like this in our equation. 108 equals W plus 3 times W. Now, to solve this, I'll need to distribute that W. So 108 will equal W squared plus 3W. And this is a quadratic. To solve it, I'm going to have to move everything to one side and factor. So I'm going to subtract this 108 from both sides. So 0 equals W squared plus 3W minus 108. And I need to factor this. So to factor, I'm going to break this into two binomials here. I know W times W will give us W squared. For 108, there's several things I can multiply, but 12 and 9 are going to be the two that work. I can put a positive 12 and a negative 9 here, and if I check, that will give me W squared plus 3W minus 108. I need to set each one of these equal to 0, so W plus 12 equals 0, and W minus 9 equals 0. So that will give me W equals negative 12, and W equals 9. But if you think about what we're looking for in this problem, the question says find the dimensions of the rectangle. So we're looking for the length and the width of this rectangle. It does not make sense to have a negative length or width. So we're going to throw W equals negative 12 out. Because of the context of the problem, it doesn't make sense to have a negative. So our width is 9 inches long, and we know the length is 3 inches longer than that, so our length is going to equal 12 inches long. So our rectangle is 9 by 12 inches. You can check to make sure that you have the right area pretty easily by just doing 9 times 12, which I really shouldn't even have to use the calculator for, but I am right here. 9 times 12 is 108, so we know we have the correct area. Moving on to the second problem, this time we have a triangle. A banner is in the shape of a right triangle, and it has an area of 63 inches squared. The height of the banner is 4 inches less than twice the width of the banner. Find the height and width of the banner. So here they call this the height and the width. Sometimes when we're working with triangles, we'll call that width a base instead, but right here they call it a width, so we'll go with that. Our area formula for a triangle is area equals 1/2 base times height, or in our case here, width times height. And we know that that area is 63 inches squared, so we will say 63 equals 1/2 width times height. But again, we can't solve this whenever we have a W and an H. So we're going to have to use this piece of information that they give us here. The height of the banner is 4 inches less than twice the width of the banner. So if we write an equation for that, height is, tells me to write H equals 4 less than, means to subtract 4 from the end, and then twice the width tells me to put a 2W right here. So H equals 2W minus 4. That means I can replace H with 2W minus 4. So I will have 63 equals 1/2 W times 2W minus 4. And what I'm going to do here is distribute that 1/2 W. So we'll have 63 equals W squared minus 2W whenever I distribute there. And I'll subtract 63 from both sides because I want this to equal 0. So 0 equals W squared minus 2W minus 63. From here, I need to factor. So to factor this into two binomials, I'll need a W here and a W here. For 63, I'm going to use -9 and +7 for that. That means my answers are going to be W equals 9 and W equals -7. However, just like the last problem, we need to disregard that negative answer. So W equals 9 is our answer that we're going to use. Our width equals 9. See, we're still inches here, so 9 inches. The height is a little bit more difficult to find this time because last time the height was just 3 inches longer. This time the height is 4 less than twice the width, so we can just plug our 9 into this equation. So H equals 2 times 9 minus 4, so H equals 18 minus 4, so we get a height of 14 inches. So our dimensions of this triangle are 9 inches for the width and 14 inches for the height. For our next problem, a rectangular poster has an area of 190 square inches. The height of the poster is 1 inch less than twice its width. Find the dimensions of the poster. So similar to the first problem, we have a rectangle. We know here that they're calling this the width and the height this time. So area would equal width times height in this case. The problem also tells me right here that the height of the poster is 1 inch less than twice its width. So that means height is H equals 1 inch less than, tells me to put a -1 over here, it has to go on the end. Twice the width tells me to put a 2W right here. So H can be replaced with 2W minus 1. We're going to plug in 190 for our area because we know that the area is 190 inches squared. We'll have W times 2W minus 1. We're going to solve this one like we did the others. We distribute that W, so we have 190 equals 2W squared minus W. And we will move that 190 over to the other side of the equation so that we get 0 equals 2W squared minus W minus 190. And we need to try to factor this into two binomials. So we will have 2W here and a W in the second parentheses. And for 190, the numbers I'm going to use are 19 and 10. So if I put a positive 19 right here and a negative 10 here, that's going to work because I get positive 19W. I get negative 20W, which gives me the negative W I'm supposed to have as my middle term. So that means I need to set each one of these equal to 0. 2W plus 19 is going to equal 0. So 2W equals negative 19. I'm going to divide that by 2. But this answer, negative 19 over 2, I'm going to disregard because it's a negative answer. For the other one, I've got W minus 10 equals 0. So I just know that's going to be W equals 10. That's the answer I'm going to use. So my width here is 10 inches. And my height is 2W minus 1, so I will say H equals 2 times 10 minus 1, so H equals 20 minus 1, so I get a height of 19 inches. So the width of the poster is 10 inches, the height is 19 inches. Those are my dimensions for this poster. Our last problem is a little bit different, because our last problem deals with volume, and there's actually a typo on this problem. It says 4,368 inches squared. It should say cubed there because volume is measured in inches cubed. So you're building a storage box of volume 4,368 cubic inches. The length of the box will be 24 inches. The height of the box will be 1 inch more than its width. Find the height and the width of the box. So in this case, we know that the length of the box is 24 inches. So this is always 24 inches. We have the height of the box and the width of the box. To find volume, we do length times width times height. And we know our volume is 4,368 inches cubed. Our length is always 24. And we have width times height. We can't solve this with width and height, so we need to go back to our problem and look for that extra information we can use, and here it is. The height of the box will be 1 inch more than its width. So that is height is 1 inch more than the width. So that is width plus 1, or you could put 1 plus W. It doesn't matter the order there. That means that what we can do here is we've got 4,368 equals 24W, and we are going to replace the H with W plus 1. Alright, we're going to solve this much like we've done the other problems. We're going to distribute here, so we get 4,368 equals 24W squared plus 24W. We have to subtract that 4,368 from both sides of the equation, and whenever we do that, we are going to get 0 equals 24W squared plus 24W minus 4,368. So we're going to pull out our calculator here because these numbers are getting pretty big, and it would be nice if all of these are divisible by 24. So let's check to see if 4,368 is divisible by 24, and it is. We get 182, so we're going to divide everything by 24. And whenever we do that, we get 0 equals W squared plus W minus 182. And so here we've got to factor that. This is still pretty big numbers, but not as bad as what we had. 182, let's see what will go into that. 182, let's see if it's divisible by 8. No, 182 divided by 12. No, that doesn't work. 182. I'm just trying different numbers here. 14 and here. 14 and 13 work. So W plus 14, W minus 13 is going to factor for that quadratic there. So we will get W equals negative 14, which we will disregard, and W equals positive 13, which is going to be our answer. So we know that our length was 24 inches. We just found that our width is 13 inches. And then the height is 1 inch longer than the width, so that means our height is going to be 14 inches. We can always check to make sure we got that correct volume. Just get your calculator and multiply 24 times 13 times 14, and there we go, 4,368. So we feel reasonably assured that we did that problem right.